Hello everyone, my name is Connor Sturr. I'm a new master's student here at Purdue University, and today I'm going to talk to you about Asiatic Garden Beetle and mint. Just a little bit about me beforehand. I'm from Norton Shores, Michigan, which is on the west side of Michigan. I got my bachelor's degree from Michigan State University in entomology just last year, where I actually spent a couple years working with Asiatic Garden Beetle, so I have some familiarity with this insect. And now I'm down here getting my master's at Purdue with Dr. Elizabeth Long and Dr. Douglas Richmond in their labs. Our grant is provided by the Indiana State Department of Agriculture. There's the title just above it. And I just want to say a huge thanks to all of you for all your support in helping us get this grant. Um, I know some of you sent in letters of support, and that we really wouldn't have been able to get this grant without all of your support and help. So I just want to say thank you beforehand. Before we get started, I just want to go over my roadmap for this presentation. First, I want to talk about the Asiatic garden beetle, its biology and life cycle, how to identify the grub and the adult. I want to look at damage for the grub and the adult, and then also go over some management strategies that we have so far. After that, I want to go over the goals of this grant and what we plan to do over the next couple years. First, looking at what is the economic threshold for AGB and mint, specifically the grubs. It's information that we don't have right now, and what we really want to find out and provide for you guys. And also which insecticides and biocontrol agents are most effective in mint in controlling these grubs. And then after that, I'd like to show you guys the results from our greenhouse experiment we did this winter. I'm very excited to show you guys, so without further ado, let's get started. First, I'd like to go over the biology and life cycle of this insect. The Asiatic garden beetle is an annual insect, so it completes its entire life cycle in just 1 year, going from an egg laid in the soil to a grub, and while in this grub stage, it'll go through 3 instars of growth, from first, as you can see on the left, to second, and then finally to third. And after the third instar, it'll then go through pupation. Here's what the pupa looks like over here. And after pupation, it'll finally emerge as an adult, completing that entire life cycle. When it comes to feeding, the Asiatic garden beetle, both the grub and the adult, are not picky. They'll feed on many different kinds of things, whatever really they can get their hands on. However, the adult is nocturnal, and they'll only really be active at night in the summertime. They'll emerge when average nighttime temperatures reach 65 degrees Fahrenheit, but they'll really only be crawling at that point, on the ground or on plants, wherever they are. And once average nighttime temperatures reach 70 degrees Fahrenheit, they'll begin flying in and around the field or even dispersing to other fields. However, it's important to note that the adults are not considered pests in mint. As many plants as they feed on, they do not seem to feed on mint leaves. So that's a very important thing to distinguish, because it's really only the grubs that are being pests in mint field, and you really don't have to worry about the adults chewing on the leaves. When it comes to laying eggs and also just kind of hanging out during the daytime, both the grubs and the adults prefer these moist, sandier soils. The adults love to lay eggs in them, and then also during the day, they like to go down into the soil and just hang out until nighttime when they become active. But they really like it when the soils are moist, and especially when they are very sandy. Here's the Asiatic garden beetle's life cycle as it appears in the field. Starting at the beginning of the year, the grub is in this dormant overwintering stage where it stays around 8 to 12 inches in the soil, and it doesn't feed. It just kind of stays there until the soil temperatures warm up. And once they start to warm up in the spring, the grub will then move up through the soil and begin feeding on roots again. And it'll continue feeding on roots until around May or June, when they begin pupating. And after they're done pupating, they will then emerge as adult beetles. Adult beetle emergence will usually begin in June and peak around July. And during this peak emergence, they will start to lay eggs. They'll mate and they'll lay their eggs in the soil. These eggs will then hatch into first instar grubs that around this mid to late summer, the first instar grubs will then continue feeding and grow larger into second instar, and then finally into third instar. And then the third instars will continue feeding until late fall, usually around late October. They'll begin going lower into the soil into that 8 to 12 inch range and begin that overwintering stage again. Using this life cycle, we can then point out 3 distinct timings for management. The first being around over here in the March to April range, right during planting. During this time, the soil will be much more exposed, and it'll be a lot easier to both sample, gauge whether you have a high enough infestation, or if you have an infestation at all, and then make an insecticide application to that bare soil, or use any kind of management strategy that you intended to use at that time. But that bare soil is really a lot, it'll make it a lot easier to use those management strategies. This can be done both, it can be done before planting, during planting, or even right after planting, as long as that soil is still exposed. The second timing is in midsummer, usually right after the first cutting. And right after this first cutting, the soil will again be a lot more exposed, and it'll be still a lot easier to then sample again, reevaluate whether you have an infestation or whether it's gotten worse or if it's gotten better. And while that soil is exposed after the harvest, you could then make your second application or make a second go around with another kind of management strategy. This is what we would call a preventive strategy. The third timing is around the end of summer or start of fall in September, right around the second cutting. If you intend to have a second harvest, right after the harvest, you can again see that the soil is more exposed, and it'll be a lot easier to sample again and determine whether you have an infestation, and then use those management strategies. And even if you don't harvest, it's still a good time to then reevaluate your infestation levels and still make an application or use another management strategy. This timing around this time of the year is what we would call a curative approach. For identifying the Asiatic Garden Beetle larvae, the most recognizable part of this insect is that it has these enlarged stipes. And now what the enlarged stipes are actually a part of the mouth parts. They're a section of the mouth part, and while on normal grubs, you can see down here, you can't really see it, or at least it kind of blends in with the head. On an AGB larvae, you can see that they're white and they're really enlarged. And I've kind of described them as bulbous white sacs, but they are part of the mouth, and they'll move around when you see the grub moving around. And that's really the key part that most people use to identify this grub. Now, if you really want to get complicated, you can look at the raster pattern. That's another way to identify these grubs. And I have here just a couple raster patterns of common grubs that you might find in the field. And then down at the bottom is the Asiatic Garden Beetle raster pattern. You can find it on the behind of any grub. If you look down where this arrow is pointing, that's where you'll look with a magnification glass of any kind. And really the raster characteristics of the Asiatic Garden Beetle are, you can see, it's hard to see here, but there's a Y-shaped anal slit. It just kind of looks like lines on the butt, and they just are in the shape of a Y. You can see here on masked chafer and the Japanese beetle, you can see this line kind of makes a little upside down crescent, and same here on the Japanese beetle. And then when you look at the raster pattern, which are these little stout hairs down here, on the Asiatic Garden Beetle, it makes an upside down chevron shape, where on the masked chafer, you can see there isn't really a pattern at all. And on the Japanese beetle, it takes the shape of a deeper V here. But down here, it's just an upside down chevron is what I like to describe it as. And other kind of behaviors that set this grub apart from other kind of white grubs is really how active they are when you find them and pick them up. If you hold an AGB grub in your hand, they'll move around and they'll be super active in your hand. When compared to other kinds of grubs, they'll really dart super fast. And another thing is that they'll bite you. They're pretty bitey as far as grubs go. And although the bite doesn't hurt at all, it just kind of feels like a small pinch. You can almost barely feel it. It doesn't really hurt, but if you pick up a grub and it starts to move around and maybe even bites you and pinches your skin in your hand, It's another telltale sign that you have an AGB in your hands. Now I have here the Asiatic Garden Beetle adult compared to a couple other look-alike beetles that you may find in the field. And to identify the adult, the first characteristic you want to look for is this iridescent chestnut brown color. You can see here on the hard wings of the beetle, you can see this colorful iridescence that you can't really see in either of these other two beetles. So that's the first key characteristics you really want to look out for when looking for this beetle. And next, you want to notice that this beetle has more of a barrel shape, or I've even heard a coffee bean shape. It's even kind of the same size as a coffee bean too. So that shape is also kind of a less obvious characteristic, but a characteristic all the same. And then also another thing that compared to other beetles, when looking at them from the top down view, which I imagine is what the view you'd be looking at them when they're in your hand, is that its head is obscured in view, kind of tucked down underneath that thorax when compared to these other beetles. You can see here in Mass Chafer, you can completely see the head, and even in the Oriental beetle, you can see the head as well. But when you move on to the Asiatic Garden Beetle, its head is just barely in sight. It's tucked under that thorax, that second part, main body part of the beetle, and you really can't see it when they're crawling around or when they're in your hand and you're looking at them. And then another point I want to bring up again is that the adults are nocturnal. So if you see a beetle crawling around or flying around during the day, if you're out in the field, it's not likely going to be an Asiatic garden beetle. Though during the day they're hanging out underneath the soil and they're chilling till the nighttime, and then they'll come out. So if you see anything during the day, just know that it won't be an Asiatic garden beetle. Now, looking at the damage of these insects, the adults will chew holes and notches into both leaves and flowers of mainly weeds. We have a picture here of a mare's tail weed and some Asiatic garden beetles that when the mare's tail was dug up, they were hanging out in the soil underneath it. And you can see that a lot of these little notches into the leaf is chewing damage by these beetles that they will do at night. But again, they won't feed on mint leaves. They'll really only be feeding on any kind of weeds they can find in and around the fields. Now the grubs, of course, will feed on the roots below the surface. We have a picture here. Here are some plants we found in a mint field showing the worst kind of grub damage, or at least root feeding on the plants. You can see here that really only the primary roots are left from this plant. When you look at these more moderately damaged plants, they have some secondary roots, even some rhizomes. And then when you look at a completely healthy plant, they have all of their roots and really no feeding has been done. And so you can see just this stark difference between the fed-on plants and just a completely healthy plant. Here we have the tips that we have so far for managing Asiatic garden beetle. And on this slide, it's mainly just we have a few non-insecticide options for managing them, starting out with avoid planting in sandy soils if possible. And I'm just saying if possible because I know that a lot of you cannot avoid planting in these sandy soils and you just kind of have to make do with what you have. But if it's an option, you should avoid planting in sandy soils. Next, we have limit irrigation, especially in the middle months during egg laying period, because this makes a very hospitable environment not only for the eggs, which are very susceptible to desiccation, to drying out, but it also makes it very inhospitable to the adults because they like that moist, sandy soil. And if you're limiting the irrigation and that soil dries out, then the adults will not like it, and they might not enjoy going down into that soil and laying their eggs there. Next would be to manage your weedy hosts in your fields and even around the fields, because these weedy hosts are what the Asiatic garden beetle adults like to feed on, and they'll also spend a lot of time underneath them. And if you're managing them and taking away that food source, it's going to make the field as an environment a lot more unfriendly to those beetles as well. The fourth tip would be to use light traps. And they might aid in reducing adult numbers. They could bring down the population a little bit, but really they serve as a monitoring tool, and they'll let you know if you have an infestation, if you weren't able to find any grubs, but you can put out these light traps, and if there are beetles coming to your field, either they're already in your field or they're coming to your field from around, then these light traps will help you determine that. Looking at insecticides labeled for mint, we know that there are very limited amounts of options once mint has been planted, but there are a couple soil insecticides, products being Coragen and Lorsban using chlorantraniliprole and chlorpyrifos. There are a couple foliar sprays, but the soil insecticides are really what you use to control the grubs. And although we know they're limited, these are the two that are labeled for mint and can be useful for controlling grubs. For the next part of this presentation, the more exciting part, in my opinion, I'd like to go over the goals of this project that's funded by the ISDA grant. Just an overarching goal that we have for the entire project is we'd like to establish new management strategies for this insect in commercial mint. And I know I touched on this a little bit earlier, but the questions we want to answer include: what is the economic threshold for AGB grubs in mint? And also, what insecticides or biocontrol agents that we have would be most effective in the field? For the economic threshold, what we really want to find out is how many grubs can you find in the field before you know you're going to lose money, before that damage is high enough and you start to actually lose crops and lose money. And then we can know the number of grubs it takes before you know management is required, so you don't get to that point where the loss is too high and you're going to start losing money. Because if the population is low enough, you might actually not need to manage it, and then you can save money on insecticide sprays or anything like that. But if it does get to that point where it's too high, you're going to want to get it under control before it gets to that, that point of no return. And how we plan to do this is we want to take 3 visits to 2 row mint and 2 meadow mint fields. And why we're doing both row and meadow mint is for the reason that we don't really know if this economic threshold, this number of grubs you gotta find, is going to be different in row mint versus meadow mint. Since row mint is still in its first year, it's not as established as a meadow mint field, it might actually take less grubs or fewer grubs to reach that point. So we want to figure that out for all of you. And the reason why we're going to go out and visit these fields in May, July, and August is we're going to be sampling for grubs. And so in May, we want to sample for those 3rd instar grubs that are coming from overwintering in the winter and then through the spring. In July, we want to sample for those really young 1st instar grubs that are the most susceptible. We want to know how many are hatching from those eggs that were laid in July. And then in August, we're moving back into sampling for grown-up 3rd instar, possibly some 2nd instar, but mostly those 3rd instar grubs that are going to be there for any kind of curative options that you apply in the fall or in late summer. And how we plan to do this is when we get to those fields, we're going to be soil sampling to find these grubs and estimate these populations. I actually have a visualization so you can kind of see what I'm talking about. So if this was our so-called field in the summer, we're going to be splitting it up into a grid-like pattern with a bunch of different plots or squares within the field. So as you can see here, this is what a field may look like. We're going to split it up into this grid, and at the center of each plot, we're going to take a soil sample. That's what all these dots are here for. And so we're going to soil sample at each dot to determine the population at each plot and take that as an average for the entire field population. And also in each plot, we're also going to look at the roots of the surrounding plants and kind of get a feel for what the root damage is in each of these plots. And we're going to take that those number of AGB grubs that we find, and also taking into account what kind of damage we're seeing, and we're going to correlate that with the yield of that field. And with that, we would like to develop this economic threshold so that you, the growers, can know how many grubs it takes before you need to start applying those management options. Moving on to the insecticide evaluation, we don't really have a concrete list of insecticides that we know are going to work in controlling AGB grubs. And that's why for this part of the project, we want to do on-farm plot trials directly in the fields so that we can create this list of insecticides that you all can use. In order to do this, we want to create plots directly in the field that will be treated in July and September. This will be mimicking that preventive and curative timing that I had talked about earlier. In July, we'll be mimicking the preventive timing that will control those susceptible first instar grubs. And then in September, we'll be mimicking the curative timing that will more control those third instar grubs that are still in the field. And after we treat plots in July, we'll come back in September and do soil samples and see how effective our applications were. And then in September, after we make that application, we will come back the following spring and evaluate how well those insecticides do. The insecticides that we're looking into, we don't really have specific insecticides in mind right now. We're still picking and choosing. But the insecticide classes we're looking into include the diamides, neonicotinoids, organophosphates, and we're also looking at insect parasitic nematodes for a biocontrol option where they'll go into the soil and directly attack the grubs. We also want to let you know that we're taking into account the price of these insecticides as well. We don't want to just choose the most expensive ones and have you all break the bank just to have these options, but we're going to take that into account and make sure we don't, we choose, affordable options for you all. And we're also going to take into account the pre-harvest interval so that the options that we do choose, you'll be able to get those applications in without having to worry, is it going to mess with when I have to harvest? So that's also something we're taking into consideration. For the final part of this presentation, I'd like to go over our 2020 greenhouse experiment, which was just completed this past winter. Now, the goal of this experiment was to evaluate how does grub density affect plant weight, and we wanted to simulate first-year rodent plants in the greenhouse. In order to do this, we harvested rhizomes and planted them into 4-inch pots with soil made from 1/3 potting mix and 2/3 sand to kind of simulate that sandy soil mixture that these grubs love so much. Now, we divided these 24 plants into 4 different densities of grubs. We had 6 plants infested with 0 grubs as our control. We had 6 with 2 grubs, 6 with 5 grubs, and then 6 with 8 grubs. And you can see here, this was a snapshot of the first week, the day we infested with grubs. And you can see this arrow's pointing to a small grub here at the surface of one of the pots. And then here's the halfway point, a snapshot of week 4, and you can already see that some of the plants are doing very well, and some of them are hurting quite a bit. And we ran this for a total of 7 weeks. And then after the 7 weeks, we harvested these plants and cut the above ground biomass and then weighed that and set it aside. And then we washed the soil off of the roots, the below ground biomass, and we weighed that as well. We also decided to dry both the above ground and below ground biomasses just to get that moisture out and kind of remove any variability and weigh that as well. Although we found out that the moisture didn't really provide any variability, and we were able to go ahead and use the fresh mass that we weighed. For the results of this experiment, we took the fresh above ground weight and fresh below ground weight and compared it to the grub densities using a linear regression. And you can see here on this graph, we have on the y-axis the fresh above ground weight in grams and the grub density in grubs per pot down here on the x-axis at 0 grubs, 2 grubs, 5 grubs, and 8 grubs. These dots are the averages among the 6 different plants that were in each treatment, and then this line is the linear regression. And you can see that it shows a downward trend when you increase the grub density per pot. And when you look at the fresh below ground weight, also measured in grams, it looks fairly identical to the graph of the fresh above ground weights, showing that, it's very similar when these grubs are feeding on these plants. They're all very negatively affecting them and kind of showing the same amount of damage, even though that, this scale is a lot lower than the fresh above ground weight scale. It's still fairly identical. But the take home message here, besides this idea that increasing grubs definitely gives you lower weights when you measure them, that even relatively low grub densities can negatively affect these rumen plants. Even at 2 grubs, you can see a very stark difference between the weights in both fresh above ground weight and fresh below ground weight. Now, we also saw this interesting behavior that we just called a clipping behavior, and that's what caused a lot of these weights to go down, because a lot of the plants actually died, and we saw the grubs actually clipped the plants from the stem and then kill the plant altogether. However, we don't really know if this will happen in the field at all. We have seen some similar anecdotal evidence that it has happened in other systems, but we just don't know if this is going to happen out in the field. So there's no telling, but it did happen in the greenhouse, so we thought it was very important to at least mention it. We also wanted to look into the survival rate of these plants. And here I have graphed the plant mortality on the y-axis, which is just the number of plants that we counted that were dead at the end of the experiment, versus the grub density once again on the x-axis. And we found that even the relatively low AGB grub densities can cause mortality in these rumen plants. And although there wasn't really a major trend as we went up in grub density, it just kind of shows that any of these densities, especially the lower ones, are going to have this great effect on the plants and cause mortality. And now we've reached the end of the presentation, and I just have some closing statements and some take-home messages before I let you all go. Now, just to reiterate our project goals, we want to determine the economic thresholds for AGB grubs in both rumen and meadowmint. Again, we think there could be a difference since rumen is a little less established and could be more susceptible. And then we also want to determine which insecticides or biocontrol agents are most effective, and not only most effective, but also, very cost efficient for all of you. And I know I just went over it, but the greenhouse findings, the major take-home points would be that increased grub density is causing the average plant weight to decrease. In that trend you saw a couple slides ago, there is that major decreasing trend when you go from the lower grub densities to the higher grub densities. But given those relatively low grub densities, they're still causing a lot lower of a plant weight and even mortality in those rumen plants when compared to that control that doesn't have any feeding. And so I just want to say thank you for listening and being with me for this presentation. I'm very excited to get to work with all of you for the next couple years, and I'm very excited to find a solution to this problem and go on in this project. If you have any questions, here's my email down here. Feel free to send any emails my way. If you have a Twitter, you can follow me for any kind of project updates. And I hope to meet a lot of you in the coming years. Thank you.